Welcome everyone to the last session of this Friday morning. We're gonna talk Gradle. So Gradle, I think, is usually a love-hate relationship for Android developers. So I hope at least I can give you some pointers in trying to improve the relationship more towards the love level, because build happiness, right? So in order to break the ice, I have a few questions for you. Who has a long build? Okay, so we see a couple hands. Does that mean you are above an hour? Few folks? Okay, so that's already pretty good. 30 minutes and more? I see a couple hands already. 5 minutes and more? More hands? Makes sense. Less than a minute? Oh, no one. Hey, hello world, maybe, yeah. So one of the things we say at Gradle is that we want your build to be as fast as possible. We don't care whether we're talking about reducing your build time from 20 minutes to 10 minutes or whether we're talking about reducing your build time from a minute to 20 seconds. What matters is that if it can be faster, then you should aim for that because it can give you benefits for your CI costs, for the time it takes to merge a pull request, for your local developer loop. And so there are a number of features inside Gradle, and that's what we're going to discuss today, that can help reach those objectives. Honestly, if you have 6,000 modules, you will not be below a second. Like, let's be realistic. But if you have a medium-sized application, there are good chances that you can get really, really good build times. Who has something that they would qualify as a complex build? So we see a couple ends. So the others think it's pretty comfortable. So that's good. Who is happy to use a build tool? Well, I still see a couple ends. That's nice. Thank you, folks. I appreciate it. But let's be honest, right? As an Android engineer, your goal is to develop features for the application you're trying to give to the users. It's not to mess up with the build. And so that's another reason for making it fast so that you don't have to, look at it too often. So I'm going to start with a quick introduction. Then I want to clarify a few things around, what is Gradle, what is the Android Gradle plugin, and why sometimes when you have an issue, you should talk to us or talk to Google. Then we'll talk about concepts and definitions around performance, because the moment we talk performance, we need to set some expectations and have an understanding of what we're talking about. Then we'll talk about the elements inside Gradle that help improve the scalability. And then I've got a few tidbits of information on what's coming next, where are we with the Gradle releases, what are we looking forward to the next months and maybe years for some stuff. So Gradle has existed since 2008. Last year at Google I/O was the 10 years of Android 1.0. That's when they also announced 10 years ago that Gradle would be the default build system, but Gradle existed before then. And one of the way we can work on that open source tool is because we have a data platform called Velocity that allows you to look at build scans, see dashboards, and effectively have a comprehensive understanding of how your build is working and how it's evolving over time. And the idea is that it is a data platform. We collect data from local and CI builds, so that gives us visibility that you usually don't have with your CI/CD pipeline only. And it allows us to do something to help you do build performance management. It simplifies also debugging and figuring out problems with your Gradle builds. That's everything I will say about that. If you want to know more, come to the booth. For the rest, we're talking about open source features that you can enable in your builds. So the idea, the vision we have for the Gradle build tool is that it's an open source build system. We want to automate the process of building software, but not any software, like software of any type, size, or complexity in a fast and reliable manner. And we understand that our vision is not yet the reality. There are difficult elements, there are frustrating elements, some stuff is slow, and there are places where we can do better. Gradle itself is a configuration and execution engine. So we look at your build files, we figure out the model of your project, and then we execute what's necessary in order to produce whatever you asked. It could be assembling the debug variant of your application. It could be running some tests, whether they're unit tests or UI tests. It could be deploying the application to the Play Store. All of those tasks, when you ask them on the command line, they require some work to be done and a task graph to be created and executed. We then offer a set of APIs that allow to build abstractions on top of the core Gradle types for common development tasks. And then we have a series of core Gradle plugins that enable developers to describe their build and leaving then Gradle responsible for the orchestration of the execution. And so if I go to the Java ecosystem, this is the core application plugin from Gradle. You apply it in the plugins block. It's something you've seen in Android build files. And then you configure repositories, a set of dependencies. And because we're talking about an application in a JVM land, one of the things we need is what's the entry point, like what's the main class of the application. Then on top of that, we see the Android Gradle plugin. This is produced by Google, and this integrates highly into Android Studio and the whole Android ecosystem experience. It defines models and abstractions dedicated for Android development. And since version 7.0, the version of the Android Gradle plugin and the version of Gradle, like the major versions, are aligned. So when you run today Android Gradle plugin 8.13, if it will work with 8 release of Gradle. It actually works with 9 as well, but the guarantee is that there is an alignment on the major version. And so, as you can see, the look, I mean, aside from it looks like code, but the way you configure the things are effectively way more custom to the Android ecosystem. So here we see that we have a namespace information, we have a compile SDK, we can have also default configuration that's propagated to the other projects in your build. And so this is, just to illustrate that AGP is effectively a customization layer on top of Gradle. So with that said, the moment we talk about performance, you have to measure. There are recipes and ideas and features of Gradle that I will mention today that may not work that well for your build for various reasons. Maybe your build needs to be improved, or maybe it's just that you are in a special environment and it doesn't work that well. And so anytime you do something related to performance, you have to measure, you have to verify your results, you have to measure again, apply changes, and it's an infinite loop effectively of iterating to get something that's better. On the Gradle side, what we like to cover as well or distinguish are the different development loops. The way you interact with your build while you're editing code, editing tests inside your IDE is very different than what happens on the CI environment where the whole application needs to be rebuilt with whatever has been merged last on the main branch. There are also specific cycles that are more tied to the tooling. You have that famous sync in Android Studio, right? If you've touched the build configuration, a number of your options are grayed out until you sync the project. And then, of course, some of you may become reluctant build engineers. One day your task is no longer to develop a feature, it's actually to add a plugin to your build, improve the build configuration, and that's also a very different user experience because, for example, we will see that where we optimize for the local development loop, because we know that the build configuration doesn't change, well, if your job is to change the build configuration, we can't have the same kind of results. So once we have those definitions, we have a few guiding principles on the Gradle side that we believe is important. We want the speed of your build to have some proportionality with the kind of changes you made. If what you're doing is upgrading AGP or upgrading Gradle, yeah, we do expect that we might have a lot to redo. But if what you're doing is editing a few build files and then running the tests that match those build files, then there shouldn't be much to do aside from compiling those build files and running those tests. And also, we want that the definition of the build gives a comprehensive understanding to the users. And we know that for the moment, this is definitely a place where it's a challenge because folks are mostly scared about build files, and due to the flexibility of Gradle, Orimas was saying that yesterday, it has great power, but so with it comes great responsibility, and there are ways that you can hurt your build performance by doing the wrong things in a build file. Gradle then works on two main axes for improving the scalability. One is work avoidance. That's the cheapest way of doing something. It's not do it. It's been done already, just don't redo it. And the other one is like matches the evolution of hardware these past many years already, it's parallelism. If you can do two things at once, then it's always faster than doing two things one after another. I mean, this is not rocket science so far, right? If there are questions also, don't hesitate to interrupt and ask, and then we can cover those points. So what do we mean by Gradle scalability? Well, let's take a look in practice. So I'm going to use Know in Android, right, which is one of the reference application that Google provides for Android development. It's supposed to have like all the modern features and all the modern recommendations. The few things I've done in it is I've added, first thing is we released 9.2 Wednesday, so I bumped it to 9.2, showing you that AGP 8.13 works with the latest Gradle 9 versions. The other thing I did was install the Velocity plugin and publish to the public instance we have for the Gradle build tool, so that we can look at build scans and have an understanding of what's happening inside the build. And then, just to give you an idea, I produced two different build scans. The first one is running build demo debug, and it took 8 minutes. This is pretty bad. The reason it takes 8 minutes is I'm using a fresh install, like I have nothing locally, I don't even have the Gradle distribution. I turned off all the scalability optimizations. So I'm not running parallel, I'm not running the configuration cache, I'm using a single worker. So I'm effectively giving you the idea of all the work that needs to happen in order to build your application. The goal is this should never happen. And so if we look, we can see that all the flags are turned off. So no build cache, it's off, no configuration cache, parallel is off as well. So if we look at the performance, we see that not only did it take a while to just initialize Gradle, because I had to download the distribution, prep the distribution for execution, but configuration time was pretty high, execution time was high as well. I spent tons of time downloading dependencies. And of course, since I'm effectively doing that all serially, it's the worst case, right? Anyone guesses? Then after that, I go back to my usual Gradle setup. I restore all of those flags in Know in Android, and I try to go for like a fully up-to-date build. So still running the same command, but just making sure everything is up to date. How low do we go? Minutes? Still minutes, you're thinking? Yes, yeah? But how less? 3 seconds. Yeah, actually not too bad. 3 seconds. Yes. So this is what we're talking about. Now, let's be honest. This is a fully up-to-date build. So this is still 3 seconds of overhead. Right? On the Gradle side, we want to keep that down as much as possible. Some of the things we just announced in 9.2 is that we've improved the way we can build a work graph. And so in order to determine what we need to execute, we've made some significant progress there. So this is the kind of progress that shows in this fully up-to-date stuff. But that's what we're talking about when we say we're serious about scalability. So here, of course, it means we spend 3 seconds making sure that nothing needed to be redone. The few things that we will have executed, if we go look at the timeline, and we search for tasks, that had a success outcome, we see actually 0. The idea is that we're not even talking about cache here, but we have like up-to-date checks that tells us that even recreating the archive, like the AR of the app, is not needed because none of its input changed. And yeah, I mean, then of course, like performance is much better, right? We only spent 207 milliseconds on the initialization. The configuration phase is 2 seconds. That's actually the time of reading up and creating the task graph, like reading up the configuration cache entry and loading up the task graph. So how do you go and what are the things that you can expect when you work in your application? So there, let's have a look at the app itself now. So as you can see, I've got the app running here. No, let me redeploy it. It's not there yet. So rebuilding the app and publishing it is like 38 milliseconds. Why? Because I've already done that. So everything is cached on my local machine. I've got all the state I need. Now, if I take the medium headline and I change its style to be thin, and I republish that, this is not the most interesting change. Please bear with me. I'm not an Android developer. But the idea is that it only took us 60 milliseconds, which is still almost twice as much as the previous situation, right? But we already have, yeah, it's not so visible. The thing is, I've already used bold locally to try stuff. And so if I do it again, I'm going to get a fully cached hit. So the speed is not exactly what I wanted to reflect. The idea is that by doing that, I did produce a build scan. Yes. And so here I will see that effectively some tasks needed to run, because we did need to execute. Why is it not letting me scroll? Oh, we got a zoom problem there. Sorry about that. Ah, right, it's too. But so you see that effectively we had to compile demo debug Kotlin because I changed code. And the fact that we had to compile that had then cascading effects on building the APK, deploying it to the emulator and things like that. But the reason we still have those fast times is because we are benefiting from the configuration cache. So if I look at the performance tab, sorry, let me zoom again. On the configuration side, we see that we're only at 1 second. And that's because we did a miss. That's unexpected. That's still pretty good then. Why did it miss? Am I looking at the wrong one? No, I've assembled demo debug that I did just, yeah. Cool, so it could be even faster. Wait a sec, I don't get that, let me. Too smart, too many things. Oh, that's interesting. Why am I getting cache miss? So I'm not going to spend too much time on that, but I'm going to investigate because I was not expecting that. I guess that's what you get when you try to do demos. But here, of course, we're looking at a very minimal change where the only thing I'm changing is a value in a single class. So that's what we call an ABI change. And so as we've seen, there is almost no cascading effect on compilation because the only thing I changed was internal to an implementation. I just recompile that module and then assemble my app. That's it. Now, if I go into the top ad bar and I rename that, now this is an ABI change, right? I've changed the name of a component, and so everywhere we're using that component, there needs to be influences. So one of the cool things we've recently released is that you can now see the build scan timeline directly in your IDE by installing the Develocity plugin. This is just a free plugin. It does not require a Develocity server. This is purely local. Nothing goes out to any server. It's only on the machine. And this shows then like the load on the machine, but also it shows me what's happening, like what are all the different tasks that are running. And so, of course, I'm doing compile demo debug Kotlin on core UI, but then I end up doing that in a number of other places because we're using the output of that compilation unit for our compilation elsewhere. We still saw, though, that this was a very fast execution, right? Six seconds. So we are no longer below a second in terms of execution because more work needs to happen. But so you see that we're here talking about a project that has been well optimized for your local development loop. Whether you do a non-ABI or an ABI change, you really get something which in terms of development experience can be really great. So how does this all work effectively? Like I said, two main axes. One of them is work avoidance. I didn't show it to you, but dependency cache was definitely at play. Like I didn't change any of the dependencies, and so whenever I'm building something, I should not get anything downloaded. The dependency cache is something that's gonna work locally on your development machine. It's gonna help with build logic and synchronization, because unless you change dependencies, you can refactor your build logic. You still don't need to download anything. It works well on CI as well, as long as you have agents that keep state around. If you have ephemeral CI, which is why I added that column specifically, and you see it has lots of red, unfortunately, but if you have ephemeral CI agent, it requires a bit more work, but there are easy ways, and it's documented in the Gradle documentation, to restore the dependency cache so that you can limit the downloads. Because let's be honest, when you do ephemeral CI and you go to Maven Central or to your internal repository every single time, you're just exchanging the trust in the disk for the trust in the network. Because this is not what's gonna mess up your build, or your subsequent builds. We're talking about downloading a binary. If that binary is correct, whether you download it every time or leave it on disk, it's the same. The aim of ephemeral CI is try to not have dependency on stuff produced by your build so that they can poison later executions. But a third-party dependency usually doesn't play in that place. We should have had configuration cat sheets. Like I said, sorry about that. I'll have to figure that out. And CC is definitely something that is tailored for the local development. That's where we believe it shines. That's where you get this sub-second testing or redeployment of your app. That's where you get stuff for a couple seconds when you've changed some ABI in some lower level components. Of course, the configuration cache is about caching the configuration. So if you work on the build logic or on the sync process, it usually implies that you've changed the configuration, and so you will not get a configuration cache by definition. On CI, it may work if you keep state. On ephemeral CI, it just doesn't work. This is not a cache that we expose remotely because it contains lots of local path and things like that, and so this is not something that is that can be reused that way. The up-to-date check, that's what I explained to you. How did I get to that 2-second or 3-second re-execution of everything? We do not even repackage the app. That's because we know that what we have locally on disk is the output we had the previous time we ran the packaging. Compilation avoidance, that was part of the ABI. You saw it when I just changed the font size in the main view. Just that element needed to be recompiled, nothing else. And there again, those benefits are mostly for you locally. On CI, up to date will be much harder because it implies that you're effectively running elements of the same thing 2 times in a row, which if you have a large project could be the case, right? Because engineers could be working on a subset of the app, and then all the rest still is up to date on a given CI runner as long as it's not ephemeral. And then of course, none of these apply for ephemeral. We also have the local build cache, right? So the local build cache is what I explained to you when I went back to Bold and I ran that. It was really fast. That's because I had run Bold earlier today. And the difference between the local and the remote build cache, aside from having almost all green flags everywhere, is that the local build cache allows you, when you on your machine switch branches, to go back to a state that your machine knows about. The remote build cache is about you coming in the morning, updating the code with whatever your colleagues did last day, and then running that locally, and then not having to compile anything. Because everything has been compiled on CI, has been uploaded to a remote cache, and then you get all of those outputs of task execution downloaded to your local machine and reused. So build cache is different than the dependency cache, right? Dependency cache is third party. Build cache is more stuff like task outputs such as compilation or even test results. Why would we rerun tests if you have the same inputs for your test? And if you tell me because they're flaky, I would say fix the flakiness. We have another number of features. Configure on demand has existed a long while for Gradle. It has all these attention signals because it's been incubating forever. and it will most likely remain incubating until it is removed. It helps some projects, but it has tons of gotchas and traps, and it's really complicated to reason about. And so we think that configuration cache and isolated project, which I'll mention soon, are better ways of getting a similar benefit. When you develop a task, and that's stuff that has been done by Gradle, but also in the Android Gradle plugin, the given task can be incremental. If you know that only a single source file changed, why would you recompile the whole source set and not just recompile that file and its dependents? And so this is where the task itself does incrementality. And then we have like an enterprise feature, which is predictive test selection. So that's a feature where the Develocity server will analyze the change set, and with its historical understanding of the build, will decide, oh, out of the 100 tests you want to run, only 20 are significant because these are the 20 that we see changing state when you touch that area of the code. The other 80, they usually don't give you any signal. And so we will only run the 20 that are relevant and say that the other 80 were skipped because of predictive test selection. This is a very nice feature, again, for your internal loop, maybe for your merge, but please make sure that you still have a pipeline somewhere that runs all the tests, because if the model was wrong, this is how it can learn. Like you then run all the tests, we realize there is a failure, and then we can improve the model by saying, look, you missed a connection between those code changes and such tests. In terms of development, the next step we have is isolated project. The idea there is that Gradle has historically had a mutable shared model for the project configuration, and that allowed pretty much engineers to do bad things. Even though we said don't do it, the APIs allowed you to do it, and so you could effectively, from any project, grab any other project in your build and change its configuration. You can even do that from inside a task configuration. So this is really nasty. And so what we do with isolated projects is we're effectively closing all those doors. And the effect of closing those doors, aside from requiring some work from you if you've done some of those bad things, or maybe updating plugins that have done those bad things, but the side effect we want to have is, as soon as we know that projects are independent, then we can apply incrementality to them. If only a given project changes its configuration, we do not have to reconfigure all the projects. We can just reconfigure that one. And so that's where, in terms of work avoidance, we believe this can have like a significant impact on your builds. This is still under development. We will most likely do a call for early adopters beginning of next year. But so, yeah, stay tuned. So if we move to parallelism and take a look at some of the stuff that effectively were hiding inside my demos. So first of all, we have the configuration cache. And since 8.11, the configuration cache will load and write the configuration of projects in parallel. And that effectively speeds it up a whole lot. Because if you have 600 projects, we can run a number of them in parallel, both when writing and when loading them, effectively shortening the wall clock time needed to restore the state in order to execute what needs to be executed. When you activate, and of course, all of that works mostly on the developer machine, on a CI machine that has state, doesn't work well when you're changing the build logic, and of course, ephemeral CI, it remains a problem. However, we have a question mark and not a red cross because of that third line. Configuration cache, because it's, if you want, a step before isolated project, the configuration cache imposes that at execution, you do not touch the configuration anymore. And so we know that task execution then becomes something that is truly isolated. A task only sees its inputs, modifies its outputs, and cannot mess up with the project state. Because of that, we can actually give you intra-project parallelism. So inside a project, two test tasks or two independent compilation units can actually run in parallel. And this is why you may want to still turn on configuration cache on ephemeral CI. Because it could be that the cost of saving the configuration cache entry is offset by the benefits you get from doing intra-project parallelism. There is no perfect answer. I cannot say you should all do it. This is really something you have to try and measure and decide, oh, my configuration cache entry size has been pretty well optimized, and it's small enough that the benefit of the intra-project parallelism completely negates the fact that we have to compute that entry. We've had historically parallelism with dash dash parallel for a long while. This becomes effectively a default once you activate the configuration cache. But if you're not yet ready for the configuration cache, hint, hint, you should look into it. You can still turn on parallelism. The thing is, it is not safe because your tasks may be doing unsafe things. And that's when, like with CC, we know they can't. And so it's something, again, you have to try. But if you can just do that, like no machines today should work with a single Gradle task. So do that for yourselves. Anything we download with Gradle during dependency resolution, we will do as much as we can parallel downloads. I know that there are cases where it looks serial. The sync process of getting the source files for doing the IDE indexing, is one of those steps. We're trying to improve that as well, but that's not yet the case. When you develop a given task, not only can you make the task incremental, work avoidance, but you can also make the task use parallel execution by delegating to the worker API. So if a single task from a plugin needs to do work that can be parallelized, that's one way Gradle offers to do that parallelization controlled in the Gradle ecosystem. Because one of the things we try to do also is with the worker API and with the parallelism of Gradle, we try to respect what you tell us in terms of maximum workers. One of my first contact with Gradle back then was to activate parallel, have a pretty sizable build, and then you can't do anything on your machine while the build is running. Which is nice for the speed of the build, but for a developer's perspective, it's not so nice because it means when you're building, you can't work. So there's a balance there, a trade-off. In Android Studio, when we do the sync process, Android Studio decided to aggressively activate parallel model building. Parallel model building will effectively speed up the whole sync process, but it might be challenging in the case you have builds where, again, those cross-project configuration impacts, because then you could be requesting a model for a given project and it changes another project, but because of the parallel model building, you've already requested that model. So there are challenges there, but the Android team estimated that the benefits outweighed the negatives. And effectively, it's kind of a forcing function. If it doesn't work well for your build, fix the build, which might be challenging, I understand, because of plugins and everything, right? I'm not saying any of that is easy, don't get me wrong. What are we looking for in terms of development there? Well, isolated projects, once again, but here, the idea is that because we know that your project can't configure each other, not only can we do them incrementally, but we should also be able to do them in parallel. And so that's, again, one way for Gradle to reduce the configuration phase. When you have a configuration cache miss, we still run the configuration phase, and that's one way for us to reduce that. Whenever we speak about that, we realize that sometimes there is a misunderstanding of what it means. Folks have a tendency to expect that if we give you parallel project configuration for sync, then your sync time will be divided by the number of cores. I wish. But that's not really the case. So we need to set expectations. So this is just to make you understand the challenges of performance in those environments. This is not at scale what happens when you sync in your IDE. We initialize Gradle, so we need to start Gradle. Like I said, the worst case, you don't even have the distribution locally. You start by downloading it. The best case, you already have a daemon running. You connect immediately to it, and then you start working. We run the configuration phase. If we have IP enabled, that happens in parallel. And then Android Studio builds its model. And that also happens in parallel, as I just explained. But so we see that the impact of isolated project will just be on the configuration phase. On average, this is 30% of your sync time. 60% is on the model building side, and 10% is like initialization plus some levels of coordination. And so if we apply the logic of, oh, is to divide my time by the number of CPUs? Well, it's going to divide 30% of your time by the number of CPUs. The 60% is already parallel. The other 10% is something that we will work on trying to reduce. But you see that the relationship is not the same, or is not as you could expect. And to be even more specific, it's a bit harder than that, because while you cannot configure cross-project, Gradle projects still have a hierarchy. And so you must configure the root project before you configure any of the child project. And if you have multiple levels of your hierarchy, this applies as well. So if you think about your project as a tree, the only thing we can parallelize is every layer in the tree. And so that's also something that needs to be understood. So even the 30% is not going to be a direct relationship of being divided by the number of cores, unfortunately. That's what I had around scalability. I hope I give you ideas and justifications for trying some of those features of Gradle. Take a look. Normally, they're well documented, and you should be able to try them out for yourself and measure the benefits on your build, and maybe speed up everything for everyone. That could make you the hero of the team for a while. So what's next? Yeah, whatever. Gradle 9. Gradle 9 is actually released, so maybe that one should have been before the previous slide. So we released Gradle 9 on July 31st. I think Android 9 is still cooking, but should come out in the coming weeks or months. And that will effectively have a baseline on one of the 9.x releases. We're already at 9.2, like I said. We released that last Wednesday. And so we have a number of good things in there. So first of all, we moved to Kotlin. Oh, damn, I missed that update in that slide. It's actually 2.2. So my bad, my slide is outdated. We actually, because it took us a while to release, Kotlin 2.2 was released, and so we integrated in it. So we are using Kotlin 2.2 in Gradle 9, and we are using language version 2.2. We've done stricter nullability for the Gradle APIs with gspecify. We moved to Groovy 4 for those of you that are still using Groovy build files. We raised the bar for Gradle execution to Java 17, so you no need Java 17 to execute Gradle 9. Worker compilations testing that still can run through tool chains with Java 8. The configuration cache has no errors anymore from any of the core Gradle plugins. However, some plugins still disable it because we couldn't make them fully compatible. It has 2 years and more of API cleanups. Do yourself a favor. If you want to do that Gradle upgrade, go to the latest 8.14 first. Make sure you have 0 deprecation warning, and then attempt the upgrade. It will be a much better experience. And then in 9.2, we had a couple performance improvements and memory usage reduction. So I would recommend you to take a look if you're already there. After Gradle 9, well, we're still looking at declarative, right? It was mentioned yesterday during the panel by Tor as a way to potentially improve the reliability of sync. We've done the compatibility and extensibility research, and we're looking at what will be the plan for productizing that and how to make sure that we can have something that you can adopt iteratively as soon as possible versus, waiting 2 more years to have a big bang change. So we're looking into that right now. In terms of IDE sync, again, mentioned yesterday during the panel, we're working hard with the JetBrains and Studio teams to try to make the sync process more resilient. Right now, if you sync with a new API of AGP or Gradle and it breaks, autocomplete in the IDE is stuck on whatever was available on the last sync. And so usually it will not highlight the error, it will not help you autocomplete to the new API that replaces a removed API. And then, of course, we've got continued maintenance and evolution, performance improvements, memory usage reduction, bug fixing. As part of the performance improvement, we have ideas that if we made Kotlin script compilation parallel, it's currently serial, it could significantly help the performance of builds that uses Kotlin without any change from you, because the compilation step is safe. Like, there are no things you can do at compilation that would have impact on multiple projects. So I'm not promising anything, but that's definitely for us an interesting avenue of exploration. We have the Gradle build tool roadmap, which is public. If you're interested, you can follow that. And yeah, that's what I had for you today. And I think we've got a minute for questions.